Welcome to the Carboline Tech Service Podcast, the go-to industrial coatings podcast. Here are your hosts, Jack Walker and Paula Atzemis.
Be sure to hit like, subscribe, and set your notifications to on so you never miss any important YouTube content from Carboline. Welcome to another edition of the Carboline Tech Service Podcast. I'm Jack Walker. With me, as always, is the Director of Technical Service. That's Mr. Paul. Wait for it. Atzemis. Also joining us this week is our Marketing Manager for Water Wastewater. That's Brian Cheshire. So if you might notice, I think this means quarantine's officially over.
It sure does. All three of us are sitting in the same room.
Within 6 feet of each other.
Absolutely. Well,
that's probably not a good idea.
You can't put this many big guys in a room without a wide-angle lens to begin with. We couldn't be 6 feet away.
Yeah, Melissa, you'll be getting that requisition form for that wide-angle lens to get me and Paul on camera. So anyway, here we are. We wanted to try something out where we're all in the same room and see how it goes. So Brian, you come on, every so often. We've talked a lot about wastewater treatment plants in the past, and there are some slight differences between wastewater treatment plants and water treatment plants. So let's first start off talking about water treatment plants and how they differ from the wastewater treatment plants.
Yeah, sure thing. So as you know, wastewater is we're typically collecting storm water. We're collecting obviously other undesirable water coming from businesses and houses, and we're treating that and basically getting it to a point where it can be released back into the environment.
That's a really polite way to say it.
Yeah.
Undesirable.
Whereas, we clean the poo.
That's right. Yeah, but whereas on potable water drinking treatment plants, these are typically going to be a completely separate division. All things considered, if you go into a town, let me ask you this, where would you typically find the drinking water plant and the wastewater treatment plant historically?
Hopefully the drinking water plant would be upstream of the wastewater treatment plant.
Ding, ding, ding. Yeah. Typically the highest elevation, because they want to rely on gravity to help them distribute all the treated water. So today we're going to be talking about really the process of taking water from surface water from streams, rivers, lakes, and turning that into a product that we can ingest safely.
So we're talking about that final step of the potable water process.
That's right.
Which we have talked about the potable water linings and stuff in the past with you. So
that's correct. Yeah.
Kind of bring it all together.
Correct. Yeah, but I would say probably more on the water storage side. We really haven't gotten into the actual treatment steps, I guess,
right,
before we're getting there.
Yep.
So.
Sure. And, back in the day, I'm not sure if this one still exists, but if you're from St. Louis and you've been to the St. Louis Science Center, we used to have a water fountain. And this water fountain had this tank that was see-through that was the most disgusting water you've ever seen. I don't think there was actually poop in it. But when you would push the button on the water fountain, the tank would go glub glub to make you think that you were drinking processed water. And so that's kind of what I think about here a little bit as I think back to my youth with this water fountain that I'm not really sure if it was drinking out of that water, but every kid was always like, I don't know, do you want to drink that? And then if the kid went and drank from it, you'd always make fun of the kid. And it's funny, but that process is kind of what we're talking about.
Yeah. Yeah. So why don't you give us a little bit of a history as to the water treatment process for drinking water?
Yeah, sure thing, Paul. So, if you're a history buff, dating back to ancient civilizations, pretty much every ancient civilization was founded near a water source.
Yep.
They were concerned about quantity of water. Quality of water, they didn't really know as much about. So.
Montezuma's revenge.
Correct. So over time, there were different methods that got introduced to really improve the taste and the odor of water. There's history dating back to 1500 BC where Egyptians actually used alum to clarify their water supply. And so it's been around for quite a while, but it really wasn't until the 19th and 20th centuries, late 19th century, when you started getting pandemics, which unfortunately sounds familiar now.
Yeah, no kidding.
And they were able to trace some of this back to the water supply. And so there really became a research push after that into how do we eliminate these microbes and bacteria that are causing these pandemics.
Absolutely. That is a real source for a healthy neighborhood and environment and society, is having clean water to be able to drink.
Correct.
Absolutely. So let's take that next step. What is the process when they get that water? What is the first step in that process?
Yeah, so typically a community is going to pull from generally one of two sources. It's either going to be groundwater, which is going to be aquifers, and then there's surface waters, which are going to be lakes, rivers, streams, ponds, so on. So generally they're going to intake from those sources. They're generally going to have screening to capture some of the bigger objects, because you don't want shoes and washing machines and other things, trying to go to the treatment plant. So heavily regulated industry. So it's intake, shipped to the treatment facility, and then they start the dosing process with chemicals. Is really the first step. But after that, then you start seeing a process called coagulation or flocculation, which is really aiming to remove dirt and other particles. And so within that process, you're taking alum and you're adding it to the water in a mixed tank. And I don't know if you have a thing that bleeps things out, but I'm seriously not about to say a bad word. But anyway, but this alum is added to the water in the mixed tank, and it forms these sticky particles called floc. F-L-O-C. Okay. But these attract dirt particles, and what ends up happening is as they go through this process, they end up going to a sedimentation basin from there, slows down the flow, gravity takes over, heavy sediment settles to the bottom.
So really what Brian's describing, if anybody hasn't seen it before, if you have a swimming pool, you do this to your pool periodically. You'll put flocculant, you'll add to it so that it gathers up all those little particles. And in a swimming pool, you're looking at, dead skin and anything that falls out of the sky. You've got pollen and all the other stuff. You're trying to gather it up because sometimes it's too thin to even get into your filter properly. And you can add this to it. That's really what this first step is. So we use it all over in society. The water treatment process really has mastered this for the rest of us to be able to use in other steps.
Yeah, most definitely. Yeah, so after, I would say, coagulation, flocculation, sedimentation, then the water has to be filtered. And so they'll run these through, granular media like sand, charcoal even. There's various different forms of media out there. But more or less, it's just, still a pretty primitive system, I guess. It's simplistic in nature, been around forever. But the goal is to remove a lot of those smaller particles.
If it ain't broke, don't fix it. Mm-hmm. It's a system that's become very refined, easy to work with, easy to maintenance.
And so from there, you filtered out a lot of the particles, but the problem is you really haven't killed the microbes or bacteria. So that's where chlorine treatment and then even some advanced treatment methods like ozone, and I'm sure you run into a bunch of them, because there's a lot of emerging contaminants and new processes to really look at.
We've seen a lot of ozone has been a big one. UV sterilization has been a big one lately. Just some other ways to help maybe reduce some of the chemicals that are being used for something that's less chemically. Ozone's in the atmosphere, it's a gas. It kills a lot of stuff. Peroxides are another one. You see a lot of peroxide in those. Yep.
And I think that's an important step to talk about real quick. I know that we're going to talk a little bit more about coatings that you find later on, but one of the things that happens here is this is frequently a misinformed call for a recommendation at this stage of the treatment. Because very frequently you will get a call that something needs to be resistant to a caustic or an acid at very high concentrations. And then you have to remind whoever's calling that those high concentrations of basic and acid solutions are going into gallons and gallons and gallons and gallons of water, so you're really reducing your concentration. So you don't need something that's resistant to that pure slug of chemical that goes in. You need something that is going to be resistant to the entirety of the thing when it comes.
And on that note, the other thing that you see a lot of is the call that misinterprets when somebody says, we need something, it's in an NSF system. I need my 93% sulfuric acid tank to be potable water approved. Sulfuric acid is not potable water approved. It is not potable water. You're putting it in at parts per million to do these clarification processes. So a tank lining that has to be resistant to sulfuric acid at these concentrations is not always the best candidate to also be potable water approved.
So where's the next step in the process after this?
So really, after you've gone through all those steps, you've disinfected. A lot of times they will end up storing that treated water on site in a reservoir or clear well, and then from there it's typically distributed either to homes or businesses, or even in some cases, depending on the system, stored in another storage tank along the way. But a lot of that depends on the elevation, depends on the cost of transporting it. Really how far do they have to go, and what kind of terrain do they have to go over to get there.
So then, now that's kind of the process, and we're familiar with the process. What are some of the substrates that we find in these treatment facilities?
Yeah, so it's really the same that you see in wastewater for the most part. But one thing to remember is, typically this is going to be a less caustic process, I guess, where we've talked extensively about hydrogen sulfide attack and some of the different things that happen in wastewater systems. You don't have that near as much here, but you do still have to consider water chemistry, looking at the pH of the water, the total dissolved solids, alkalinity, hardness. So there are different levels of service that have to be considered, and it really depends on the system, the water makeup, the water chemistry. So it's definitely important to ask a lot of those questions.
Yeah.
I would say on the front end. But I would say one thing on the coating side, when we're looking at coating concrete, so in these first few stages, you're still treating this water. So you don't necessarily need NSF certification this early in the process.
Sure.
However, pretty much every specification I see, they require that it be NSF throughout all of these different concrete structures. And so that has really become a necessity, and that's something you see a lot of. And that may be, a 3-coat epoxy system. It may be a 100% solids epoxy, or even a 100% solids polyurethane, but all having that NSF designation.
Yeah. It kind of makes it a little easier for the people who are putting the systems together if they just say, yep, it's all approved. They like that step.
Well, do you think there's anything to, maybe they don't want to introduce anything, they're trying to filter the water, so they don't want to introduce anything new or even early in the process?
Yeah, that's a big part of it. You're introducing an additional contaminant that now you've got to treat for.
Sure. Absolutely.
So I definitely understand the methodology there.
Yep.
But on concrete, you do see some atmospheric exposure as well. Such as I mentioned the clear wells on site. Mm-hmm. Those have to be coated on the outside generally. A lot of times they'll have just an elastomeric acrylic material, just something really to protect it against wind-driven rain and keep water from penetrating from that side.
Yeah.
So other than concrete, what do you find?
Yeah, so there's still a lot of steel, and there's a good bit of ductile iron in these facilities. And so often with steel, and really with ductile iron as well, you're having to color code, because there's a lot. If you've ever been in a treatment plant and been in the pipe galleries, there's a lot of pipes.
Yeah.
Yep.
And they have to be color coded depending on what's coming through it. And so if it's interior exposure, epoxies are okay generally in that sense. Obviously outside urethanes, you would want that to be your top coat to give the UV protection. But one thing to really consider though is on these substrates, when you get into these pipe galleries, these are very damp areas. A lot of sweating.
Yeah.
And so this is where your phenalkylamines and some of your surface tolerant materials really come into play. And we're even seeing too, and I'm sure you get calls on this, but we're seeing coatings used for condensation control as well, which is a totally different animal, but they're looking to somewhat eliminate the problem there.
Yeah.
Because it is such an issue in these plants.
Yeah.
Phenalkylamines are really important when you're dealing with sweaty pipe.
Correct. But I would say the last thing I wanted to talk about, I guess, within the treatment plan and talking about coatings, with a lot of these emerging contaminants, you hear a lot of news about like the firefighting foam, PFAS, and some of these other chemicals, what they call forever chemicals that can't be broken down.
Right.
The way to attack that is some of these advanced treatment methods. And so we're really seeing an uptick in like reverse osmosis, ultrafiltration, membrane type technology. And so the key to those is basically these membranes are catching a lot of the really fine particulate, but over time they have to maintain those. And so they end up having to backwash these tanks. which can become a very abrasive environment. So I would say if you're looking at a structure in that portion of the plant, that's where you really need to consider something like a aromatic polyurethane that has good abrasion numbers, or even some reinforced systems if it's quite a bit of backwashing.
One of the terms that we frequently hear and say, especially with the carbon filter tanks, you hear the phrase in situ regeneration, which basically is just you're taking the carbon filter media, or in some cases a sand media, and they do a multi-stage wash where they'll bubble through like a sulfuric acid wash and then a caustic wash and then a neutralization wash. But all that happens inside the tank that has the filter media in it. So they don't take the filter out, the media out, they leave it in, and it gets bubbled through, and it helps to purify it, and it reactivates the carbon, so that way it can filter stuff again. And that process, now you have to have a potable water tank lining that's resistant to sulfuric acid, resistant to sodium hydroxide, and is still potable water rated. That's where you really get into some specialty coatings that require a lot of good abrasion numbers, good chemical resistance.
And as we're finding out more about, this has been an ongoing process. We talked about dates back to 1500 BC, but I would say there's still discoveries that are happening surrounding water treatment. So as we continue to, I guess, evolve with the environment and new contaminants, you're going to see more and more of these different approaches, and then even different configurations. That's one thing I did want to point out earlier, talking about the process. There's really no cookie cutter way to do a plant. Right. They may be in all kinds of different orders and different combinations. So you really can't walk into plants and expect them to be the same.
Right. Yeah. That is something you see a lot of is you have to ask, what's your design? What do you look like? What do you have going where? Because they're all unique.
All right. Well, we're getting a little long on time, but before we stop, I wanted to bring up, Paul talked about some of the specialty coatings and the need for specialty coatings. What are some of the Carboline products that we use in these areas?
Yeah, so, talking earlier about some of the core products, some of the NSF epoxies, products like our Carboguard 635 VOC, even get into 100% solids materials. We're talking phenylene tank shield. And then on the polyurethane side, we're talking Reactamine 760 or even 760 HB if it is a very abrasive area.
Yep.
But I will say too, there's another part I didn't touch on, but when you get into a treatment plant, there's also a lot of pumps and other equipment. And with Carboline's recent acquisition of Dudic, they actually have a line of materials that are designed to repair those. Okay. And so, yet another solution that now we can offer.
Absolutely. They've got a fantastic line of steel repair materials to be able to go in and fix when you have impellers that are damaged or pump parts that need some reinforcement to them. They've got a great line of liquid steel kind of products to be able to go in and do those repairs. Not to mention supplementing for secondary containment systems, reinforced systems. There's a lot of great offerings. So although we've always had a very comprehensive offering, the recent acquisition of Dudic has greatly expanded the offerings that we're able to bring as a full service supplier into these industries.
Well, and I'm glad you brought up secondary containment, because if you've been in a water treatment plant, there are quite a few chemicals that are stored on site. And so having, I guess, a robust line, I guess, of different options to be able to address that is very important, because different chemicals act differently.
Yeah. Dudic, being a concrete specialty company, has always they've got a great line of grouts and concrete leveling and surfacing products that we're able to now offer as part of the Carboline offering.
All right. Well, that's it for the Carboline Tech Service Podcast this week. Brian, thank you very much for joining us again.
Thank you, guys.
Thanks, Brian.
All right. For Paul, for Brian, I'm Jack. We'll see you guys later.
Who put the